Hello everyone, welcome to School Math Simplified. We are continuing the chapter number 4, that is Quadrilateral for class 8 Maths Ganita Prakash. And today we will solve the figure it out of chapter number 4. So let's heading towards the first question, that is find all the other angles inside the following rectangles. You are given with two rectangles. As you can see, only one of the angle is given in both the rectangles. You need to find out all angle inside these rectangles, right? As you can see, there are these marks on the diagonals, that is representing the property that is the diagonals are equal and bisects each other. The property of diagonals, okay? So you need to revise it and apply it here. Fine, so let's start and solve the question number 1. See, we have the diagram here. First diagram is this. You are given only 30° here and we are going to find out all the angles. So I'm starting with this part only. As 30 is given to you, you can easily find out this part of the rectangle. How? As you know, all the angles of a rectangle are of 90°. So this angle is also of 90°. If one part is 30°, then second part will be of 60°, right? So here I'm taking it angle 1. This is angle 1, say, right? So you can write as angle 1 plus 30° is equals to 90°, right? So angle 1 will be 90° minus 30°, which is 60°. Clear? So you are with angle 1. Now moving to the next angle. This is angle number 2. Okay? Now just look at here. As you can see, this is a sign of equality, right? Means if I'm taking this as O, the center part is O, this means that OA equals to OD. If OA is equals to OD, then this implies angle 1 will be equals to angle 2. Why? Because in a triangle, if two sides are equal, then the opposite angles also will be equal, right? So angle 1 is equals to angle 2. So angle 2 will be of 60° also. We have this angle now, right? Now moving to the next angle, that is angle number 3. Now this is quite obvious. If one part is known to you, then the other part can be easily known because this whole angle is of 90°, right? So angle 2 plus angle 3 is 90°. Yeah. So angle 3 will be 90° minus 60° because angle 2 is of 60°. Okay. So angle 3 will be of 30°. Yeah. So this is angle 3. Now moving to the next angle. This is angle number 4. Now see again, if you have, as you can see, these equality signs. So this is implying OD is equals to OC, which is implying angle 3 equals to angle 4. That means angle 4 is of 30°. Why? Because angle 3 is of 30°. Angle 3 is equal to angle 4. And if this is angle 4, then clearly angle 5 will be of, yes, 60°. So angle 5 will be 90° minus 30°, which is of 60°. Yeah. So now angle number 6. Angle number 6. So again we are applying this property, equality. We are using the equality of triangle. The opposite sides will be equal. That means angle 5 is equals to angle 6. Why? Because OC is equals to OB. Okay, which is equals to 60°. If angle 6 is 60°, then quite obviously angle 7 will be of 30°, right? So angle 6 6 plus angle 7 is equals to 90, which is leading us angle 7 is equals to 90 degree minus 60 degree, which is of 30 degree. Hope these are clear to you. But we are still left with some parts of some angles of this rectangle. This is the angle number 8, angle number 9, angle number 10, angle number 11. Okay, solve them now. This is easy. We are using triangle sum property. We are taking any of the angle, any of the triangle here. So let's take it in triangle AOB. Get here. In triangle AOB, you have three angles. That is 30 degree plus angle 8 plus angle 7 is also of 30 degree, right? And the sum of all these angles will be of 180. That means angle 8 will be of 180 degree minus 60 degree. This is 120 degree. That means angle 8 is equals to 120 degree. And see, just look at here. Angle 8 is equals to angle 10. Why? Because they are vertical opposite angles, which is 120. They are vertical opposite angles. Here. Now we are left with 9 and 11. Any of one is known, then the other one will be equal to that one, right? So to find angle 9, we can use linear pair as angle 9 and angle 8 both are made on a plane line. Can you see that? Right? So angle 8 is already known. So angle 8 plus angle 9, this is of 180 degree. That means angle 9 will be of 180 minus 120 degree, which is 60 degree, right? And clearly angle 9 is equals to angle 11, again vertical opposite angle. Let's prove. Okay, solve the second part of this question now. We are given PQRS, a rectangle, and again you have equal diagonals which are bisecting each other. 110 is given to you, angle 110 is given to you, then clearly this is angle number 1. How we can find angle number 1? See, angle number 1 and 110, they are linear pair. Okay, so angle number 1 will be of 70 degree. That is 180 minus 110, which is 70. Yeah, and this is angle number 2. Angle number 2 is equals to 110 directly. Hope you are getting that because they are vertical opposite angles. Okay, so angle number 2 is equals to 110 because this is of vertical opposite angles. And angle number 3, this is angle number 3. Angle number 3 will be equals to angle number 1, which is 70 degree. Again, vertical opposite angles. Yeah, we are now with these angles. Fine. Now just take any one of the triangle. So let's just take this point as O. This is O point in here. Okay. So in triangle EOS. Okay. If these two sides are equal, then clearly this angle will be equal to this angle, right? I'm taking this as A. Both angles will be of A. Right? So let's solve it. Angle A plus angle A plus angle 2. Angle 2 is of 110 degree. Is equals to 180 degree. So 2A is equals to 180 degree minus 110, which is 70 degree. So angle A will be of 70 upon 2. That is 35 degree. Yeah? Angle A is of 35. That means this angle is also of 35. So we can take it as 4 and 5. This is angle 4 and this is angle 5. So angle 4 equals to angle 5 equals to 35. Yeah. So now take it as angle number 6. Okay. Now obviously this whole is of 90 degree. If one part is of 35 degree, the other part will be 90 minus 35 degree. So solve it here. Angle 4 plus angle 6 is equals to 90 degree. So angle 4 is already 35 as you have solved, and angle 6 will be 90 degree minus 35 degree. See, 5. Angle 6 will be of 55. If angle 6 is of 55, angle 7 will also be of 55. So angle 6 equals to angle 7 equals to 55 degree. Clear? If angle 7 is 55, so angle 8. Again, we are using that. Every angle, corner angle will be of 90 degrees. So the other part of the 7 plus angle 8, 90 degree. So the angle number 8 will be 90 degree minus 55 degree, which is 35. Again, this is 9, angle number 9. If 8 is 35, then angle 8 equals to angle 9 because of the equal sides. This is also of 35 degree. And angle number 10. Angle number 10 will be of 55 degree. Why? Because angle 9 plus angle 10 is equals to 90 degree. So angle number 10 is equals to 55 degree. And angle 10 and angle 11 both are of 55 degree. Okay? Because of equal side. Proved. We are done with the second part also. This is how you can easily find out. Let's go with the sequence, right? Okay. So question number 2. Question number 2 is draw a quadrilateral whose diagonals have equal length of 8 centimeter that bisects each other and intersect at an angle of 30 degree, 40 degree, 90 degree and 140. So see how to solve it. Which is of 8 centimeter. Okay, we are drawing a line which is of 8 centimeter. This is of 8 centimeter. Take it as A, and this is, yeah. Now take the midpoint of this. See, as you can see, the midpoint of this is of 4 centimeter. Can you see this? This is the midpoint, right? We are taking it O. Take this as O. Okay. I'm just erasing portion because I need for something. Okay. This is of 8 centimeter. I'm writing here. Now we will draw an angle by placing the protector here and draw the angle 30 degree. Angle is of 30 degree. This should be here. And we will draw an angle 30 degree. We will extend it on both the sides. This extend the line on both the sides. Both the sides, the line will be extended. Now, you need to mark 2 points on this line, which is of 4 centimeter, 4 centimeter each. So let's mark it point 0 from O to 4 centimeter. That means this point, and point below, which is also of 4 centimeter, is this point. Need to draw 2 points which is of 4 centimeter and 4 centimeter each, and name them C, B. C and B. Now you need to join A, B, C, D. So this is our required rectangle. A, B, C, D. The required rectangle. A, C, B, D is required. Right? So this is how you will solve each and every part of this question, 40 degree with 90 degree and then with 140 degree. Yeah, you can easily use. Now this is how you will solve each part, 40 degree, 90 degree and 140 degree. First, the angle that I have made at the center with on the one side of the diagonal, you need to draw these angles and complete the rectangle. Fine. Moving to the next question. Question number 3. Consider a circle with center O. Line segments PL and AM are two perpendicular diameters of the circle. What is the figure APML? Reason or experiment to figure this out. Okay. So this question, a circle with center O where AM and PL are the two perpendicular diameters. You need to find out APML. APML. That what is this figure? You need to find out this. Okay. And you need to, state the reason also. Fine. So now in this figure, PL and AM both are perpendicular diameters of the circle. Obviously, they are the diameters of the circle passing through the center. Fine. If this is the radius, this is R, this is R. So obviously, this is also R, R, and R. These are the radiuses. So what is the length of PL now? PL is equals to PO plus OL. This 2R. Right? And same AM is also of 2R. What is this defining? This is defining that PL is equals to AM. That means the diagonals are equal, right? They are equal. So this, see the quadrilateral APML. These are the diagonals. PL and AM are the diagonals and they are equal. And the great thing is that they are bisecting each other also. See, OP equals to OA equals to OL equals to OM. all are of r length, right? That means they are bisecting each other. Okay. PL and AM are equal also. They are bisecting each other also. So the quadrilateral is square. Okay. So APML is square. Here PML is a square. Moving to the question number 4. We have seen how to get 90-degree using paper folding. Now, suppose we do not have any paper but two sticks of equal length and a thread. How do we make an exact 90-degree using these? C and D. These are the two sticks of equal length. Say they are of 6 centimeter each. They are of 6 centimeter. Okay. Now mark a point. Mark the midpoint of the stick using the ruler. So say M is the midpoint, right? And fix a screw here. Screw to be fixed here, right? Now use a thread. Measure the distance between AD and BD. And keep moving the sticks about the screw so that the distance AD equals to BD. Your new position will be like this. You keep moving with the screw to get the sides AD and BD equal. You will get this diagram, right? Now consider triangle AMD and triangle BMD. These are the two triangles, right? And in these triangles, we have AM equals to BM because M is the midpoint, right? MD is common, and right now we already positioned the thread like AD is equals to BD. So we have three parameters that are equal. First is AM is equals to BM because M is the midpoint. MD is common and AD equals to BD. This is what we have proved just now. So by which criterion? By SSS, because these are the three sides, right? By SSS criterion, triangle AMD is congruent to triangle BMD. If these are congruent, and also if these are congruent, then AMD, this angle, and BMD, this angle, both will be equal, and they are linear pair also. They are equal and making linear pair. That means they both are of 90 each, right? Because by CPCT we are saying by CPCT angle AMD is equals to angle BMD. They are of linear pair also. So angle AMD plus angle BMD is equals to 180 degree. Case of linear pair. This implies both are of 90. Both are 90 degree. Yeah? So the angle between the sticks will be of 90 degree. This is what is asked in the question. How to make the exact 90 degree using. So this is how we make it. Okay. So last question of this figure it out is, we saw that one of the properties of a rectangle is that opposite sides are parallel. Can this be chosen as a definition of rectangle? In other words, is every quadrilateral that has opposite sides parallel and equal a rectangle? So the answer ABCD, let ABCD is any quadrilateral. Say this is any quadrilateral in which opposite sides are parallel. If ABCD is any quadrilateral where AB parallel to CD is parallel to CD and BC is parallel to AD. Yeah? And also they are equal. So in this quadrilateral, opposite sides are equal. For ABCD to be a rectangle, we require each angle 90 degree, right? If we want to prove this is a rectangle, we need all the angles are of 90 degree. Given information that AB is parallel to CD and BC is parallel to AD, cannot help us to prove that each angle of ABCD is 90 degree clearly, right? The given information is already given that is only given that the opposite sides are parallel and equal. Right? So with that information, we can't say this is a rectangle. A rectangle cannot be defined as a quadrilateral with equal and parallel opposite sides. Yeah? For that, we need to prove that the angles are of 90 degree. But with the given information, we can't make them. Okay. So that's all with the figure it out of this chapter. So we'll continue the next topic later on.